So, characteristics of log functions with a base 10 and base e. Now, base e is not going to be a huge focus of what we're doing, right? But we will look at base e and base 10. Both of which, for log and log base e, you have keys on your calculator that do that, right? So you can graph these. So we're going to look at is, anybody do chemistry? So you've seen the log, like pH, right? pH is negative log, blah, 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 right? And your chem teacher just said, find the word log on the calculator, right? Go negative, hit that key, put in whatever. But never explained to you like what a logarithmic function is, right? So it's a function of this form, y equals a log base, that's the base. Just like an exponential function has a base, right? Like y equals 2 to the x, the base is 2. The x is the exponent, right? The y is the value of. And actually the way it turns out is that a log function is the inverse of the exponential function, right? So you think of, if we have y equals x squared, what's the inverse of squaring something? Square rooting it, right? What's the inverse of the exponential function? It's the logarithmic function, right? And it just has a fancy word in there, but it's just an operation, right? So you see the word log, and log, whatever, right? It's just an operation, tells you what to do. Today, we're not so much worried about what the log is, but what does that function look like, right? So what are the characteristics? And we did this with exponential, right? What are the characteristics? So all we're going to do is just flip over to here, and we say, so I've graphed two functions, y equals a log base b of x. Now, here's the thing. The base can't be a 1. Right? Just like with the exponential function, you can't go y equals 1 to the power of x, because all you're going to get out of that is 1s, right? 1 to the power of anything will just be a 1. So it doesn't make sense. So it makes sense to have a base. Now, we're going to use a base of 10. So this is what the logarithmic function looks like. Okay? Like got values going way down here, comes up. It's got an x-intercept of 1. Do you think that it's going to cross the y-axis somewhere? No, not really, right? Remember, the exponential function didn't cross the x-axis, and in the same kind of a way, the logarithmic function won't cross the y-axis. So we can move this over a bit and kind of up a bit. So that's what the log function looks like. So which quadrant does it start in? Quadrant 4, and it goes to quadrant. And what's it doing? Increasing. Okay? So that's the word you left off of the test last week, right? It said, the instructions said, fill in the table below for each exponential function. Describe end behavior as from which quadrant to which quadrant and increasing/decreasing. So pretty much everybody did the Q2 to Q1, and then less than half of you did the increasing, decreasing, right? So we want both pieces of information, right, with an exponential. They all go Q2 to Q1, so you're not telling me that much if you say it's an exponential function going from Q2 to Q1, really, because they all do, right? But what is it that's going on? Oh, it's a growth function, so it's increasing, it's doing that, or it's a decay function, so it's decreasing, right? So it's a cup of coffee that's cooling down, the temperature is decreasing. Right? Or it's a financial application that's going up, so it's increasing. All right, now, and we'll quiz that stuff on Wednesday, right? So this Wednesday, seeing as we're going to do a Wednesday thing for a couple weeks now, I'll have a quiz. It'll be in 302, first period after lunch, so wise time in here, and then period in there, 4 topics. Right? So the last 2 topics, where did we end off with? RFK, which was solving exponential equations. So you'll have the next couple of things after solving exponential equations, which is whatever they are. I'll tell you in a little bit. And then there should be 4, right? Which will include today, so characteristics of the log graphs, and whatever we do tomorrow, which is like 7.2. All right, so I'm going to play with the a value, right? This is y is equal to log base 10 of x. If you graph it in your calculator, this is what you're going to look at, right? You'll graph y equals log x. This is what you'll see. What happens with the a value? So I'm just going to hit play on here, right? And it'll increase to 10, and then it'll decrease to negative 10. And you're just going to watch and say, all right, what's going on? Press go. Come on. There we go. Oh, what happened there? It's going from which quadrant to which quadrant? 1 to 4. Okay, now it's 4 to 1. So if the a value is positive, where do we go? Q4 to Q1, and what do we say? Increasing. If the a value is negative, then it's Q1 to Q4, decreasing. That's almost implied, right? I mean, if you're going from Q1 to Q4, you have to be decreasing. But, you know, although it's a little redundant, Q1 to Q4 decreasing, it still just allows us to say, I'm going down, right? And then if a is positive, Q4 to Q1, and it's increased. So if the a value gets bigger, what's changing? Is the x-intercept, has that changed at all? Because we've got this a value that's playing, and say, that's not changing, right? But when we did y equals a times b to the x, we know that a was the y-intercept, right? So it changed, and we saw this graph was moving up or down. This one just seems to be, in a sense, kind of pivoting around that value of 1, right? Like it starts off as Q4 to Q1 increasing, and it's just that point is a constant, right? So what can we say about the x-intercept? It's equal to 1. Okay, is anything changing that? Okay, and let's pause that. Let's play the b value. Okay, has the x-intercept changed? No. What happens when b is negative? Disappears, right? Oh, right. We can't have a base that's negative, right? But, okay, here, let's stop playing this. So there's log base 10, but the a value. So let's reset a to 1. By typing in the value 1. 1. And getting rid of that because I don't want that. And the b value, so here, let's set. Now we can't have 1 for a base. Let's put in 2. So if it's 2, so as the b value is increasing from 2, what's happening to the curve? Kind of, so let's just say, let's just play from 2 to 10. I'll just set 2 to 10. Steps, well, let's go 0.1. Play. Okay, b value increases, the curve is doing what? Is it steeper or less steep? Less steep, okay? So the smaller the b value, kind of the faster it's going up, right? So it's always, we got an a value of 1, we're just leaving that, right? So that we're not introducing something else. A value is 1, b value I've got going from 2 to 10, and we can say that, okay, as the b value increases, the graph gets less steep, right? So the smaller b is, the steeper it is, and then as b keeps going up and up and up, it's increasing but at a slower rate. Okay. Now, let's take b to b. What am I doing? Let's make it 0.5. Okay, so what's happening here when the b value is 0.5? It's going from Q1 to Q4, and it's decreasing. Right. Okay, that's the first time we've seen that, right? We had Q4 to Q1 increasing, Or did we see when a was negative, did it go that way too?
Yeah.
Okay, so if the a value is negative, then it's Q1 to Q4 decreasing. If the b value is between 0 and 1, then it goes Q1 to Q4 and it's decreasing. The x-intercept is always 1, right? So the x-intercept hasn't changed, doesn't matter what we do. Let me set the a value to play. So it's Q1 to Q4 decreasing, the a is positive. When a goes negative, now it's Q4 to Q1 increasing. Okay, so there's a couple of ways to get this curve to either go Q1 to Q4 decrease. We can do that by having a b value greater than 1 and an a value which is negative. And there's a couple of ways to have this go from Q1 to Q4 decreasing. We have a b value between 0 and 1 and an a value that's positive. And if the a value goes negative, then that's what's going on. Okay, so let's stop that. I said stop. And let's get rid of that graph. So here is the graph of ln, log base e. So the way to say log base e is ln. Okay, so log base 10, that b value is a 10, right? And that's mostly the one we're dealing with. So let me go back to this. B value is 10. Okay, let's put that away. So mostly we're looking at this graph. Log base 10 of x, it's going from Q4 to Q1. It's increasing if the a value is positive. And the bigger the a value gets, the less steep it gets, right? Now we'll look at that tomorrow. Why is that? What are these values? What does this mean? Right there. The one's gone. We're still missing one person. So, no, I didn't take out any desks. We have 32 desks and 33 people. I just don't think that's ever going to be a problem. We'll see. So mostly we're looking at base 10 log, right? That's what you're looking at. We can see the a value. If it changes, the larger positive that it gets, the less steep the graph gets. And if it goes negative, then it's flipping over. Okay, pause. Disappear. This is base E, still has an x-intercept of 1. Okay, if I play the C value, then the bigger C gets, okay, remember that's like the A value, right? So if it goes negative, it's flipping to underneath. And otherwise, as it gets bigger, this gets steeper. Okay, so we're not changing the base. All right, so those are, go stop. Go away. Compare that to this, and all we will do is change the a value. We'll leave the base the same. And I don't have this graph showing. Show. Don't show. Showing. You can see when it's, well, we can leave that. So when A is negative or C is negative, you're looking at kind of the same idea going on. And then as A increases, the graph just gets steeper. Okay, and the same thing happened when C was increasing. So if C increases, it gets steeper. As A increases, it gets steeper. Okay, stop. And big thing is you can do all of this on your calculator, right? All you have to do is graph y equals log 10x or put a number in front. Okay, and these are the values that you would get out, right? Which we don't really care about. These are the equations that you'll get out. Okay? So if I ask you to graph something where, you know, y equals log 2 log base 10x, you can graph that, right? That's all this is. You can do that on your graphing calculator. You can graph 5 log base 10x and compare it. As the a value goes up, what's happening? Well, it's increasing at a faster rate. My x-intercept is always 1. It doesn't matter what I did, whether it's log base 10x or 2 log base 10x or 5 log base 10x. What are the characteristics? So that's just discussing what we've seen, right, happening. Ln of x is just a log base e. Okay, so if we discuss, how many x-intercepts are there? There is 1. What is its value? So there is 1 x-intercept, and it is always equal to what's it always equal to? 1. Okay, so at least you can't go wrong. Because if I ask you the number of x-intercepts, you're going to say 1. And if I ask you what is the x-intercept, you're going to say 1. So whether you're saying the right thing for the wrong reason, the answer is the same. What is the y-intercept? None. End behavior. So it's either Q1 to Q4, doing what? Decreasing. Or Q4 to Q1, increasing. If you're not sure which is which, just graph it, right? So if I ask you what is the characteristic of y equals 2 log base 10 of x, just say there's 1 x-intercept which is equal to 1. There is no y-intercept. It goes from, okay, let me graph this. Oh, it turns out Q4 to Q1 increasing. What's the domain? Can I go back here? X is greater than 0, right? Can't be equal to 0, right? There's no y-intercept, so x is greater than 0. X greater than 0, not greater than or equal to. What's the range? Y is an element of the reals. Okay, you can see because we're doing this, right? We're going from all the way down there, and it's heading up on an angle, so it's going to go all the way up there, or it's coming from Q1 to Q4 and it's decreasing. It's going to cover off all of the possible y values. All right, anything there? Nothing exciting. Unique characteristics. Okay, we've talked about those. Okay, matching equations. So there's exponential and logarithmic functions. We want to match them. So let's pop this down a little bit to, yeah, that'll work. Okay, so figure out on your own which is which. Okay, and then we'll talk about which is which. Right? So there are 2 exponential equations and 2 logarithmic equations. And you have to identify which one is which. All right, y equals 5, y equals 5 times 2 to the x. Is that exponential or logarithmic? Exponential. Has a characteristic. What is the 5? The y-intercept. So we're looking for y-intercept of 5. So maybe there. It doesn't look like, right? It's going there, and that one's kind of down. All right, so it looks like that one is B, right? Also, this goes from Q2 to Q1 increasing, right? We know this is increasing because the B value is greater than 1. We're looking for an exponential increasing function. This is B. We're looking for an exponential decreasing function. Which one is that? That one is D. Again, right? Because it goes Q2 to Q1. Exponentials go Q2 to Q1, regardless. Right? It could be increasing or decreasing. B is between 0 and 1. It's a decreasing. Okay, 6 log x. And negative 2 ln x. So 6 log x is which one? C. Okay, so log function with positive value, right? That's base 10. So if you don't see a base written in the log, then it's assumed to be a 10. You see the word log, and they don't have a little number down there, it's a 10. So just a log base of x, a 6 log base of x goes Q4 to Q1. This one is negative, so it's going to take that, basically flip it, and go, no, sorry, that's the exponential one. It's going to take it and flip it. So it's going to go Q1 to Q4, and it's decreasing, right? And that's what that negative does. Flips it over. All right, you could obviously just graph all 4 of these, right? So if you got to ask this question on the floor, you could just graph 5 times 2 to the x and say, okay, which one does it look like, right? Which graph is it? So there's ways around that in asking questions, right? Which is just to say y equals a times b to the x, and say b is greater than 0, tells you it's a growth function. A is greater than 0 tells you that you're going to be, somewhere up there, and it's an exponential growth. Okay. So basically ways to not give it away, right? And then here's the answer. They're just saying, I matched these up, and since this is has these characteristics, then I know that it's this. Okay. Since a is greater than 0 on the function y equals 6 log x, I knew the function matches the graph of an increasing function. Okay. And since this is -2, it's a decreasing function. Key ideas. Logarithmic form has the form a log base b to the x, where b is greater than 0. We don't have to worry about negative values of b, right? We didn't even see a graph when we got into negative. A cannot be 0. If a is 0, the whole thing becomes 0. You can't have a as 0. A and b are real numbers. All logarithmic functions of the form have these characteristics. The x-intercept is 1. This is not the number of x-intercepts. It is the x-intercept is always 1. There are no y-intercepts, right? This is the number of y-intercepts. It's not the y-intercept, okay? Make sure you're reading that when you're doing the questions. You really want to look at that and say, is that the number of them, or is it the value of them? In behavior, Q4 to Q1 or Q1 to Q4, we add a descriptor, right? Anytime we are describing any functions, we say it's Q1 to Q4 increasing, sorry, Q1 to Q4 decreasing, or it's Q4 to Q1 increasing. Okay, so make sure you're adding a descriptor. Domain, x is greater than 0. Do not write greater than or equal to 0. Can't be 0. And the range, y belongs to the reals. Here are the characteristics. If a is greater than 0, the function increases. If a is less than 0, the function decreases. Okay, remember, we're mostly sticking with log base 10. Okay, so just think of what the log base 10 looks like. It's doing this. Can't draw. Right? Doing this. So if a is greater than 0, this just takes a point here and just multiplies it by a. And if it's negative, then it goes down, right? So if this was a 2, we double it, it becomes a 4. If we multiply by -2, it becomes a -4. That's going to flip the function, right? So it'll be a decreasing function. Need to know. Graph of a logarithmic function of the form increasing a is greater than 0, decreasing a is less than 0. Okay, so we won't play with the b values. We won't give you a b value of 1/2, right? We saw, okay, this is what happens, and it's like, oh wow, there's a couple of different ways of doing this thing. We're not going to go there, right? We're going to stick with a b value of either e, which gives you the ln, right? That's that 2.71828 that you learned about. Mostly base 10. They're reciprocal, they're inverse functions of each other. An inverse function is a reflection in the line y equals x. You could see if this were a mirror, this function would be reflected in that. And here, same thing for base e. And that's it.